world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill.
All right, hello and welcome, lads and ladettes, to Ether Roundtable 126. Tonight we're going to be doing a research and reading night. We're going to be looking at the Anomalies in the History of Relativity Theory by McCausland. This is one of the first papers that I read when I got into doing my own research, when I was looking into general relativity. And this paper had a lot of influential citations that would lead to other exciting discoveries and understandings, etc. But this was a nice foundational baseline to kind of understand what the theory was about and what and what the experiments that were leading up to its quote unquote success meant, and the implications and all of that. So it'll be nice to revisit this and give it the respect it deserves. All right, so here we go. McCausland, abstract. In 1919, it was announced to the world that the observations of the solar eclipse that occurred on May 1919 supported Einstein's general theory of relativity. That announcement was one of the most influential events of the 21st century of science. Since Einstein's instant rise to enormous fame arose directly from it. In spite of all the confidence with which the announcement was made, however, it was later realized that the accuracy of the observations was insufficient to constitute a reliable confirmation of the phenomenon that was predicted. Furthermore, another of the formulas published in General Relativity for the variation of the perihelion of the planet Mercury had already been derived by another scientist several years earlier using another method. In spite of that fact, the experimental evidence for relativity seems to be very flimsy in 1919. Einstein's enormous fame had remained intact, and his theory has ever since been held to be one of the highest achievements of human thought. The resulting deification of Einstein had some unfortunate effects. Critics of his theories are often dismissed as cranks in search of and in search of better theories that have to be inhibited. It suggests that the announcement of the 1919 eclipse observation was not the triumph of science that is it is often portrayed, but rather the obstacle to be objective consideration for alternative hypotheses. All right. Introduction. The generally accepted version of the history of relativity has been has dominated for about 80 years by the famous announcement in November 1919 that the results of the observation at the solar eclipse of May 1919 confirmed Albert Einstein's prediction from his general theory of relativity that starlight would bend by the precise amount by the gravitational field of the sun, and this announcement caused such an enormous sensation, but by both scientists and the general public, and that Einstein's general theory became world famous literally overnight. In spite of the confidence of the announcement, however, it was later realized that the observations were not particularly accurate, and the results did not, in fact, provide a decisive support for the theory. An interesting commentary situation is found in the first two paragraphs of Eddington's of the editor of Nature by John Maddox, 1995, which are as follows. Historically, the most dramatic proof of Einstein was on the right track with his general theory of relativity came in 1919 when Eddington and his associate Cromlin took themselves to the Western Pacific to track the total solar eclipse of the sun of that year. They were bent on measuring the predicted deflection of light from distant stars of the near the limb of the sun. As the world knows, the prediction was confirmed within the limits of accuracy of the observation, to general applause. Einstein became a celebrity overnight. What is not so well remembered is that in 1919, the measurements were not particularly accurate. The standard error of measurement was roughly 30%, while the displacement of the images of the star is in the field near the sun eclipsed eclipsed this by the sun ranged from half to twice the deflection of Einstein that he had predicted. And later eclipse measurements have not been much better, largely because the difficulties in making the measurements from the ad hoc observatories that have to be established. This is really interesting because the last quote unquote terrestrial confirmation of this one was uh, some guy in his backyard as a hobbyist who basically, due to the precision involved, we're talking a little over an arc second in terms of displacement. So like the measurement itself comes from mathematical extrapolation of the different you know rather than an actual displacement. So you don't actually even observe what they're claiming, the most quote unquote accurate one done today. So it's you can't even really confirm it. That quotation shows the two conflicting sides of the problem. Einstein's enormous and enduring fame resulted directly from the announcement of the eclipse, although the results were not particularly accurate. Another interesting development is the problem given by Siama in 1967. The first attempt to test Einstein's predictions was made by the British expedition led by Sir Arthur Addington just at the end of the Great War, at a time when it was considered very striking that a group of British astronomers should attempt to test a theory proposed by a German. This result was to test. The results were the test of the claimed. The results of the test were claimed as triumph for Einstein in his world fame dates from this event. Ironically enough, attempts made in later eclipses suggest that Eddington underestimated the uncertainties inherent in such a difficult observation. Even today, Einstein's predictions have not been well tested with such precision as one would wish. The purpose of the present paper is to present more details on the theory of the period in question and to attempt and assess the significance of the announcement of the 1919 observations. General relativity. In the general theory of relativity, Einstein gave a formula that correctly matched the anomalous advance of the perihelion of Mercury, which had already been observed by astronomers such as Leverrier in 1982. And this is the saying observed is not correct here. Nobody observes this. This is a this result comes out of a subtraction chain, starting with the full amount of precession that they observe, and then somehow they've broken that into, okay, this amount of precession is due to Earth's wobble. Okay, this amount of precession is due to the gravitational displacement of the moon and sun, causing a little perturbation. Like they have it broken down into all these different things, and so when they subtract everything out, there's a little remainder, and that remainder is what's in question here. And what it implies is that Mercury would be moving faster than what's expected for their model, and they don't have a reason for how that velocity increase could happen because they have to be moving, basically at a constant velocity. And so there's no mechanism for it, and they have to try and explain it. So this is it's computated by the astronomers. It's not observed by anyone. It may not even exist at all. It could just be an artifact of the math. And if you believe that the reference frame you're on is wobbling by 5,600 arc seconds per century, then trying to extrapolate 43 arc seconds out of that per century is, good luck. The general theory of relativity also made two further predictions: that light would be bent by the gravitational field, and that the spectral lines of the stars, including the sun, would appear displaced towards the red end of the spectra by the strong gravitational fields. The predicted effects of gravitation on light were so small that they caused no measurable phenomenon on the Earth itself. But the theory predicted that light reaching the Earth from the star would be bent by the gravitational field of the sun that passes through very close to the sun. Since the star whose light passes very close to the sun would usually be impossible to see, the deflection of starlight is very difficult to observe. However, such deflections might be observable during a total eclipse of the sun. And in March 1917, the Astronomer Royal of Britain, Sir Frank Watson Dyson, suggested that the total eclipse of the sun that would take place on 1919 would be a most present opportunity, or most excellent opportunity, to test the prediction of the general theory. Although in 1917, although 1917 was a dark period for the first time of the World War, Dyson undertook the organization of the eclipse expedition in the hope that the war would be over in time and the expedition would take place. Even though the war did in fact end in time for the expedition, Dyson did not go to the and observe the eclipse himself. Instead, Professor Arthur Stanley Eddington became the leader of the expedition, and the subsequent rise of general relativity was strongly influenced by Eddington's work. As a minor comment on the quotation from Simia, it should be pointed out that Eddington was knighted in 1930. He was not Sir Arthur Eddington when he went on the expedition. So that's cool. He got rewards and benefitsies. Although it appears that Dyson was originally somewhat skeptical about the possibility that Einstein's general relativity theory was confirmed, Eddington was a strong believer in the theory and was so confident that it would be confirmed. Chandrasekhar in 1987 described Eddington's influence on writing when he wrote to Dyson. Eddington's enthusiasm for general relativity theory must have succeeded in ensnaring into its magic to his close friends and associate Mr. Frank Dyson, the astronomer royal. Together, they are soon planning an expedition to observe the solar eclipse on May 29, 1919. To quote, I know that's not Jeans, it's some French thing. What is it, John's? To quote John, the state of civilization, to quote Jeans, the state of civilization should permit when the time comes. Eddington, as described in his own part in the planning and the successful outcome of the expedition, as the most exciting event that I recall in my connection with astronomy. Chandrasekhar went on to say that Eddington was so confident in the correctness of that it left himself, and that he would not even have planned to go on the eclipse expedition. Eddington was so confident in the correctness of the theory that if left to himself, he would not even have planned to go on the eclipse expedition. Okay. He just would have went ahead and accepted it. Chandrasekhar related how Eddington was a pacifist and deferred from the military service during the First War, with the express stipulation that the war should end. That if the war should end in 1919, then Eddington should undertake the expedition for the purpose of verifying Einstein's prediction. The eclipse expeditions and their observations. The two expeditions went from Britain to observe the total eclipse. Two expeditions. Professor Arthur Eddington and E.T. Cottingham went to the island of Principe in the Gulf of Guyana, in West
Guinea.
Guinea. Thank you. In
You know,
Guinea.
like the pig.
Yep. Yeah. Okay. Like a guinea pig. Okay. In Guinea, West Africa. Well, Dr. Cromlin and Davidson went to Sobral in Brazil. Neither expedition went to the Western Pacific, as reported by Maddox in 1995. Photographic plates of the stars close to the sun obtained during the eclipse were compared to plates taken in the same portion of the sky at a different time of the year when the sun was elsewhere. It should be noted that the deflection predicted by Einstein was very small, being about 1.7 arc seconds for the ray of light near the edge of the sun. And then so right next to the edge of the sun, right on the solar limb, would be one solar radii. And then as you take that same angular amount and go outward from that limb, like you make copies of it and just go outwards, that would be two solar radii, three solar radii, so on and so forth. As you get further away, the fall off for this is just like insane. So you could only even ever, like, the maximum deflection you could get to even possibly try to measure is this 1.7 seconds of arc, which is basically nothing point nothing. So just wanted to clarify on that. Since no stars for which the measurements were made during the 1919 eclipse were within two solar radii of the center, the largest deflection that would have occurred, according to the theory, would have been less than 0.8 seconds of arc, for which the 343 centimeter focal length telescope used by Eddington would have corresponded to about 0.01 millimeters on the photograph. Stone, you're our premier unit conversion analysis expert. What are we talking here? What's the
Well,
possibility that this is
that's
going
a
to hurt?
hundredth of a millimeter being a thickness of a dime, right? So
Yeah.
this is 1/100th the thickness of a dime. And this, for anybody who hasn't already figured it out for themselves, 1 arc second is 1/3600th of a degree. So that's where we're at in Fantasyland here.
That's how far deep we're in. And keep in mind, I guess the measurement uncertainty at the time was 30%. So 30% on an arc second, on 1 arc second. Okay. In addition, there were other technical difficulties because having to transport the telescope to the remote locations. For example, the light from the star was reflected by a mirror in the telescope, so that mirror could be rotated to compensate for the rotation of Earth during the time of the exposure. Well, of course, you got to account for the stars moving, for the old ball rotating. Uh, Rotation of Earth at the time of exposure instead of rotating the telescope, which was not feasible under the conditions of the eclipse. Oh, dude, that's what took the accuracy off Stone. They didn't account for the rotation.
Well, they used the mirror for the rotation instead of rotating the entire instrument. That was the problem. They didn't have a rotatable mount for the entire telescope. So they used a mirror to do the rotating instead.
Oh, right. So what's the difference then? That seems reasonable. That doesn't seem
That's about the same.
Yeah, that doesn't. Okay, so that doesn't. Okay,
but you lose a little resolution via the potentially shoddy quality of your mirror.
Oh,
you know what I mean? You're looking at second generation light, so to speak, before it enters any lens or plate.
Gotcha. Telescope is the. Oh, this is an additional component that they added to what would be a normal telescope. I see that. I see. That makes sense.
Does it give a polar alignment error for the telescope?
I've never seen anything like that in anything that I've read on this whole situation.
I think that would just result in a little bit of lateral motion of the image on the plate as a whole. So I don't think that's really going to be a factor when they're checking the distance between a star and the edge of the sun in the same exposure.
Gotcha.
Cool. All right. Possible sources of air in the observation of this type at the solar eclipse have been described by various authors, such as von Klubler and Beratotti, Brill, and Krotkov. So refraction of the sun and the sun's corona and/or Earth's atmosphere, because like we're talking such a small amount here, and any angle sub 90 degrees, they're gonna have a hard time even justifying 1 second of arc or anything more than that. So distortions of the optical system caused by temperature changes during the eclipse, changes of the scale between the eclipse and the plates for the comparison plates. So yeah, they'll get into the narrative here, but they had to use different plates and made of different materials for the comparisons and then translate that mathematically to what it would be if it had been done on the plate that matched the one that they took the observations with. Distortions of the
I don't even know that that's an error. I don't even think I would be thinking that's something you want to track because, I mean, unless they're zooming right the hell in to the edge of the sun, you could use its own curvature to establish scale because you know the apparent diameter of the sun. You know what I mean?
You'd think.
You would think. I don't even see that as a factor.
Oh yeah, dude, it was a whole thing, and Frank Dyson Watson had to get involved and come up with like an algorithm to translate how this plate would look if it were really made of the other material from the plate that they used. They had to get your boy in to solve it. They couldn't do it themselves. It was a whole project. Distortions of the photographic immolation while drying. So just in the process of drying the plates.
That's an emulsion. That's a photographic term. The emulsion.
Emulsion?
Emulsion.
Emulsion.
Yeah.
The measurements in the air and the images on the plate. Air's in the measurement of the images on the plate. Although refraction of the sun's corona could probably be not was probably not significant, the refraction of Earth's atmosphere may have been. For example, in the recent estimate of the effect of Earth's atmosphere on astronomical observation by McRobert in 1995, viewed at high power from the bottom of the ocean of air, a star is a living thing. It jumps, quivers, and ripples tirelessly, or swells into a ball of steady fuzz. No, you're just using your camera wrong and you're focusing it. You like, what are you, flat
It
earther?
emits glowing unicorn farts too if you got it at the right setting.
Rare is the night at most sites where any telescope, no matter how large its aperture or perfect its optics, can resolve details finer than 1 arc second. More typical at ordinary locations is 2 to 3 arc seconds of viewing or worse. And keep in mind, this is at really high angles. This is like looking up at like 60, 70 degrees.
Yeah, very much near the zenith, indeed.
Yeah. Yeah. Although that article was back in the Backyard Astronomy section of the journal, it seems reasonable to suggest that the conditions at Sobrel and Principe in 1919 were probably not as good as the conditions obtainable in America backyard observatories in 1995. The Sobrel telescopes were set up on a race course, and the setup was shown in the photographs were in various publications such as Eddington 1920, which I'm assuming that's a bibliography or something. The author was not aware of any published photographs of the Principe setup, but it may be noted that the baggage had to be transported about a kilometer through the woods by native carriers. Dyson's and others, 1920. They talk about how they set up everything and had it all arranged. So the setups like this were unlikely to have any better than at Sobrel. In addition to the ordinary everyday effects of the ocean of air, quote unquote, the darkening of the sun at the eclipse may have worsened the refractive effects. Distortions of the optical system that may have been caused by the effects of the heating in the mirror by the sun, and this is noted at the problem by Zabrel. Yeah, they ended up throwing out all the measurements from Brazil because Cromlin said that the temperature differential skewed the measurements. So that they ended up throwing out everything, and then it all just falls back on what Eddington says he got. So in considering changes of the scale at the eclipse of the plates in the comparison, von Kubler has pointed out that for the telescope with a focal length of about 343 centimeters, the change of the effective focal length or the focal setting of only 0.1 millimeter between the eclipse and the plates in the comparison plates, which are taken months apart, can cause scale errors of the same order of the effect that the stars were said to move beyond about 8 solar radii from the center of the sun, as the effect of about 8 solar radii. So I think 8 solar radii would be like 0.8 arc seconds or something ridiculous, like something not even like not
No,
yeah.
zero. No, solar radii in terms of apparent is a quarter of a degree each. So that's 4 degrees out from
No,
the
no,
center.
yeah, but the ratio that the deflection would be 4 degrees away from the limb of the sun
Scale errors.
would be like 0.8 arc seconds.
Huh. Okay.
According to there's a like I got the von Kubler graph. He's got a distance chart for it. I was trying to recall it. But yeah, that's how it works. So let's see here. Distortions of the emulsion while drying was probably not very significant. However, the measurements of the actual deflection on the plates may have introduced some new errors of the extremely small displacement involved, especially when the X and Y components of each displacement have to be measured. In addition to all the small potential problems, the weather was cloudy at Principe at the time of the eclipse, and the photographs obtained were not as good as expected. In one of the earliest publication references to the findings of the eclipse expedition, the astronomer Royal Frank Dyson Watson reported the following as at the meeting at the Royal Astronomical Society on July 11, 1919, before Eddington had returned from the expedition. I had a letter from Professor Eddington 2 days ago. He was hoping to get good measurements to determine the displacement definitively, but he obviously was greatly disappointed. He secured 16 photographs, but for the last 6 was the sky clear enough to show any stars on them, and he only got 3 or 4 or 5 images. And the time as this and as the sky was generally only clear for part of the plate or for one part of the plate at a time, the stars secured on the plate are badly distributed. From the best plate, however, he has some evidence that there is deflection of the Einstein sense, but the plate errors have yet to been fully determined.
Some
So-
evidence, not
evidence.
conclusive evidence, not proof, just some evidence. I love the language.
He's got some evidence with him, but we don't know how much. Like we're now reduced to 1 plate out of 16. It is interesting to compare that the reference to Eddington's own later description of his measurements of the same plate. He describes how, although the weather was unfavorable because of the cloud, 16 photographs were taken. Of the 12 that were examined at Principe, most were useless, but 1 plate was found showing fairly good images of 5 stars, which were suitable for the determination. His description of plate 116 is as follows. Or plate P16. Anyway.
Yeah, that's actually page 116.
I was thinking of that too, and I was like, maybe that's not, yeah. Okay. Anyway. Thank you. The result from this plate gave a definite displacement and in good accordance with Einstein's theory for disagreeing with the Newtonian prediction. So Einstein predicted the full amount where the whole Newtonian, after subtracting everything, had that little remainder that they couldn't account for, that they had to explain. Although the material was very meager compared to what we had hoped for, the writer, who it must be admitted was not altogether unbiased, believed it convincing. Well, that's cool. Eddington's biographer, Professor Vibert Douglas, also described the measurements of the plate, quoting from Eddington's notebook. In the notebook, the entry for June 3rd, after saying that he spent the whole day measuring, Eddington continued as follows. The cloudy weather upset my plans that I had to treat the measurements in a different way than from what I had intended. Consequently, I have not been able to make any preliminary announcement of the result, but 1 plate that I measured gave a result agreeing with Einstein. Douglas's biography continued with that statement. This was the moment which Eddington never forgot. On the occasion of his life later in years, he referred to it as the greatest moment in his life. It is interesting that the measurement on the same plate should have been viewed at vastly different ways by Eddington at different stages in his life, different stages of his study, and the findings of his expedition. At first, he was obviously greatly disappointed. Then, although admittedly biased, he believed the evidence convincing in spite of the meager results. He later saw it as the greatest moment of his life. Although he had first suggested to his letter in Dyson that the stars on the plate were poorly distributed, he claimed in a published paper that the 5 stars shown from the plate in Principe included all the most essential stars. Ooh, everything was blocked out except for everything that proves the theory. Nice. Sometimes you just get lucky. And even suggested that the clouds may have been beneficial by preventing overexposure from the brightest stars. In spite of the optimistic assessment, it appears from the published paper from the paper that he published that the stars on the 2 usable plates obtained in Principe expedition were indeed poorly distributed. Since the expected deflections, according to Einstein's theory, were radial, it seems obvious that a good test would include all the stars around the sun. But on the diagram showing the stars from Dyson in 1920, it is possible to draw the starlight line through the center of the sun in such a way that all the stars in the plate are well on one side are it is possible to draw a straight line through the center of the sun in such a way that all the stars on both plates are well to one side of the line. Okay. In fact, it is possible to draw a straight line through the center of the sun in such a way that of the 13 stars included in the combined records of both expeditions, only one, number 2, is on the other side of that line. Furthermore, all 5 stars from the Principe, plate W, stars number 3, 4, 5, 6, and 10, and 4 of the 5 on the other plate, plate X, the one measured by Eddington at Principe, stars 3, 4, 5, 6, and 11, are are almost on a straight line. Since the measurements on the Principe plates were taken by placing a Principe plate film to film with the Oxford comparison plates so that the images of the corresponding stars nearly coincide, which was possible because the Oxford plates were taken directly were taken directly and the Principe plates by reflection in the mirror. The almost straight line distribution of the stars may have worsened the accuracy of the fitting of the pairs to the plates. The diagram of the stars can be found in Eddington 2020, page 120. But by contrast, the Sabrel expedition had experienced fine weather. It had taken photographs of 2 telescopes using one similar to the Principe one and one having a different aperture and focal length. The photographers were also the photographs were also disappointing because the definition of the images had been spoiled. When the photographs taken by the eclipse with the telescope that was close to the one that was similar to the one in Principe were measured, the measurements pointed with all good to the agreement to the half deflection, that is to say the Newtonian value, which is half of the amount that Einstein inquired about. So the other plates seem to imply that it's going to deflect by half of what was predicted by Einstein, so even a smaller amount. So, and keep in mind, they said that they had to throw all those out because of a temperature differential when they compare the two. So now they've just, they isolate the comparison to one single plate. Eddington in 1920 went on to give a reason for preferring the Principe results. The astronomer at Principe had taken the plate checks from another portion of the sky to check whether there was any effect that the 50-degree difference in temperature between Principe in May and England had in January when the photographs were taken for comparison, whereas no such check for the plates were taken by the Sabrel expedition. However, the Sabrel expedition had stayed in Brazil for a further 2 months after the expedition to photograph the same region of the sky before dawn, so that it would appear that the large temperature difference would not apply to the comparison to the photographs in this case. They published the paper, or the published paper by Dyson states why it was not feasible for the Principe expedition to make a similar comparison. Unlike for the Sabrel expedition, we were not able to take the comparison for the photographs of the eclipse field at Principe because the eclipse occurred in the afternoon, and it may be many months before the field could be photographed at the same position at sky before dawn, and the plates were therefore specifically uh, the the check plates were therefore specially important for us. In any event, like it doesn't change the fact that the other ones did do the comparison where where it wouldn't matter, and it confirmed what they measured. In any event, it seems strange that it seems straight it seems strange to the state after in any event, it seems strange to state after the fact that the absence of the check plates in the Brazil expedition was a disadvantage. Either those check plates were significant or they were not. If it was considered necessary to take them, It should have been decided in advance rather than being used after the fact to downgrade or reject the whole set of observations from another location. A somewhat different opinion of importance of the check plates has been given by Miller, not to be confused with Dayton Miller, different Miller. Although the weather was far better in Sabrel, Eddington insisted on emphasizing the data from Principe. Clearly, a key part of his expedition is to use the same instrument at the same site for comparing the data for the apparent and true positions. But this was not done. The comparisons of the photographs were taken several months later at Oxford. There are also puzzling discrepancies between the two accounts, although Eddington states explicitly that there were no check plates taken at Cybrel. On another account from Dyson in 1920, states on page 298, referring to the Sabrel expedition, that a few check plates in the field near Arctis were taken but have not been used. Several authors have referred to the way in which Eddington emphasized some of the photographic plates rather than others, or emphasized some of the photographic plates rather than others. For example, Campbell wrote as follows: Professor Eddington was inclined to assign a considerable weight to the African determination, but few images on the small number of the astrographic plates. Astrographic plates were not as good as the astrographic plates secured in Brazil, and the results from the latter were given almost negligible weight. The logic of the situation does not seem entirely clear. A minor addition to the history of the eclipse expedition, it may be noted that at the same meeting where Dyson reported Eddington's disappointment, Campbell reported on the results obtained by the eclipse earlier in June in 1918 by saying, "It is of my own opinion that Dr. Curtis's results preclude the larger Einstein effect, but not the smaller amount expected by the original Einstein hypothesis, or the original amount according to the Einstein." He's referencing the Newton prediction there for what it would be for the classic gravitational theory. After the measurements have been made, there is still a mathematical problem of extrapolating back to the edge of the sun, since no stars measured are within 2 solar radii of the center of the sun, and the small changes observed in the deflection can be caused by much greater change in the computed deflections at the limb of the sun. This problem has been discussed by von Klubler and Barati, Brill, and Kratov. In particular, in Figure 6, von Klubler's paper is shows the extremely wide scattered results from the various eclipse expeditions. A more recent eclipse expedition in 1973, also described by Zerker, that's a cool name, Zerker, who shows widely scattered measurements as well, and states that the occurrence of a sandstorm limited the value of his results.
Oh, what are the odds, man?
Classic
A sandstorm whipped right on by during the eclipse.
Dude, the classic sandstorm.
Ugh.
All right. The problems of interpreting the results of the eclipse expedition have been well summarized by Guggenheimer. No way that guy's name is Guggenheimer. That's probably that's the coolest name ever. Summarized by Guggenheimer in 1925, who made the following comment in 1919 regarding the eclipse observations. Any reader, though far from the expert astronomer or physicist, who will study the description of the apparatus used in the observations and the large margin of errors possible by reason of defects therein, will readily comprehend that the view of the required delicacy of the measurement of the things observed in the air allowance for the apparatus defects and the other possible physical causes of the observed phenomenon, the greatest caution in the analysis. Am I?
Yeah, you're roboting pretty good there.
All right. Well, that's super unfortunate. Let me see here. Can you hear me now?
Yeah.
All right. I ended the stream, but I started recording when I started, so I'll just upload the full version when I'm done, just in case I lagged out. So we'll just continue as is, as if nothing happened, and then I'll upload it when we're done.
Sure.
Okay. I came prepared this time, boys. Okay. So where were we at here? This guy was giving the most eloquent summary ever made. It sounded a lot like poetry.
Around line 5 of that
Y-
summary.
Yeah, right here. Some of the astronomers deny that the photographs of the eclipse observations, when compared to those taken of the same stars in absence of the sun, show deflections approximating the amount or direction predicted by Professor Einstein. An examination of the various tables of the deflection shows that many of them are far away from the quantities predicted. The quantity approximating the predicted one is obtained by averaging a selected few observations. Oh no, are they just mathematically extrapolating things that no one's actually measured? Or that you could like never actually observe in a quantifiable way?
Well, they're
All
not
right.
extrapolating, they're approximating.
Ooh, different kind of a extrapolate. uh, Announcement of the eclipse results. The results obtained by the British expedition of May 1919 were announced at the famous joint meeting of the Royal Society and the Royal Astronomical Society. Would two royal societies collide? Do you remember that song, Stone? No.
When two royal societies collide?
Yeah, these guys got together, had a joint meeting. So held on November 6, 1919. In spite of the poor accuracy of the uncertainties surrounding the results, it was announced that the evidence was decisively in favor for the displacement that had been predicted by Einstein. Sir Joseph Thomson, president of the Royal Society and chair of the meeting, strongly endorsed this result. Thomson in 1919, or from quotes from him, the enthusiastic reception of the announcement at the meeting was matched by an enormously strong reaction by the general public, according to one biography of Einstein written by Clark, 1971. Einstein awoke in Berlin on the morning of November 7, 1919, to find himself famous. Although Fulsing has expressed a disagreement with that particular interpretation of the event, there is little doubt that Einstein arose with spectacular rapidity to the worldwide fame as a direct result of the announcement. The atmosphere of the excitement at the meeting at the meeting has been described by Alfred North Whitehead in the following words, and he just summarizes the excitement from the lads here. I don't think it's important to contextualize the excitement. Um, so we'll skip that part. The the meeting has also been described in a very interesting way by Abraham. What's that guy's name?
Pais. Pais.
Pais, who identified the day of the joint meeting as the day on which Einstein was canonized. Pais was obviously very pleased with the comparison of the meeting at the Congregational Congregation
That's
of the
you
Rights.
got it.
Yeah, Congregation of the Rights, at which the candidate is considered for canonization of the Catholic Church. They canonized him. It was compared to the various participants of the meeting of the counterparts at the Congregation of the Rights, using his reference at the New Catholic Encyclopedia. However, one of his comparisons was highly inappropriate, namely his comparison by Ludwig Silberstein to the Advocatus.
Advocatus diaboli.
The old devil's avocados. So he's playing devil's avocados. Although Silberstein was critical of accepting the results that superseded Newton's theory, the circumstances of which the criticisms were expressed were totally different in at least in at least two respects from the circumstances in which the arguments for the devil's avocados were expressed in the Congregation of Rights, Congregation of Rights. In the first place, it is imperative that the arguments of the devil's avocados be heard before canonization is pronounced, and Pye's account and whatever that guy's name is, accounts gives the impression that Silberstein's criticisms have been heard before the results were endorsed by the president of the Royal Society. However, the generally accepted account of the meeting of Thomas shows that Thomas had to use Pius's words, pronounced the canonization before Silberstein had a chance to speak. Oh no. In the second place, it is the responsibility of the devil's advocate to ensure the canonization does not occur undeservedly. In order to fulfill the responsibilities, he must be given full access to the relevant information required to make the case for the opposition, the case to opposition to the canonization. This condition was not fulfilled at the meeting at which the eclipse results were announced, because it was not possible for the members of the audience to be sufficiently well informed about the results that were being announced to make an informed criticism of them. The paper was eventually published by Dyson and others, which is 43 pages long, with copious tables of mathematical analysis, carries the notation received October 30, read November 6. Also, in this issue of Nature of the same year, also, the issue of Nature, dated October 30, carried the announcement of the joint meeting, showing that the meeting had been arranged before the paper had been received by the Royal Society. It seemed very unlikely, therefore, that the paper had received any critical review by independent referees before the presentation, or that its contents were available to the audience early enough to be thoroughly studied. Just after the astronomers had presented their results, Thomson rose and called for the discussion, or Thomson rose to call for a discussion, but before the discussion actually started, he strongly endorsed the confirmation of Einstein's prediction by saying, "It is difficult for the audience to fully weigh the meaning of the figures that have been put before us, but the Astronomer Royal and Professor Eddington have studied the material carefully and regard the evidence as decisively in favor of the larger value of the displacement. This is the most important result obtained in connection with the theory of gravitation since Newton's days, and it is fitting that it should be announced at the meeting of the society so closely in connection with him. If it is sustained that Einstein's reasoning holds good, and it has survived two severe tests in connection with the perihelion of Mercury and the present eclipse, then it results one of the highest achievements of human thought." That's a hell of an endorsement. It was that speech that Pies interpreted as the announcement of the canonization of Einstein. The remark about one of the highest achievements of human thought has been widely quoted and obviously contributed to the contributed enormously to the veneration of Einstein and relativity theory. If we pursue Pies's comparison of the joint meeting at the Congregation of Rites, we find another unfortunate feature of the comparison, namely that the canonization of a saint by the Pope is infallible and irrevocable, so that the subsequent criticism of the process is futile. That's unfortunate. Once it hath been declared, there's no undeclare. It is unfortunate that Pies, by identifying Silberstein as devil's advocate, gave the impression that the critical assessment of the eclipse and the results had been voiced at the joint meeting and that the criticisms had been answered. Let us now consider what Silberstein did say in his contribution in the discussion at the meeting. Although he did not find any fault in the eclipse observation for the reasons given above, he did not point out the fact that the third main prediction of the general relativity, the redshift in light, strong in a gravitational field, had not been observed when he said the following. There is a deflection of the light rays, but it does not prove Einstein's theory. It cannot be logically deduced from his theory as a gravitation effect in absence of the spectropic result. And as far as we know from St. John's and Evershade's observations, the predicted shift of the spectrum lines of the amount exceeding almost 100 times the probable error of the modern spectroscope is just not obtained, or is not obtained. If the shift remains unproven at present, the whole theory collapses, and the phenomenon that was just observed by the astronomers remains a fact awaiting to be accounted for in a different way. Eddington's reply to Silverstein when he described Ehrman and Gilmore, as described by Ehrman and Gilmore, as being mild and irrelevant. That's so funny because, real quick to give some contextual history here, St. John's and Evershade were the leading experts in spectroscopy, or astrospectroscopy, and there was a specific amount of redshift that was supposed to be observed when in a strong gravitational field and whatnot. So they were taking observations of different, when different heavenly bodies were near the sun, and looking for spectroscopy shifts, and they never found any. And so at the same time that Eddington and the boys were doing their observations, these two gentlemen had their assignments where they were taking spectroscopic readings from Britain to see if there was any change in the spectropic readings from the starlight, and they didn't find any deflections that correspond to what would be like the change in the frequency due to the magnitude of the gravitational field changing its angular position. So there was supposed to be a direct relationship between the two to establish the physicality of the gravitational field itself, and how that changes the trajectory of a photon, through the space-time coordinate system as it's curved due to the gravitational field. So all that was supposed to be substantiated as like a package, and it wasn't. So they don't talk about this part of it, and they only talk about the deflection, which is crazy. So that's something that Eddington or Silverstein was trying to point out during this. So all right, so Eddington knew this, by the way, but he's going to say that it's irrelevant somehow. So when a result had been forecasted and is obtained, we naturally ask what part of the theory exactly does it confirm. In Einstein's case, it's Einstein's law of gravitation. It is not necessarily that his theory that it is confirmed with the underlying assumption that the ds, which is space-time, the space-time interval, uh, so like how they describe the curvature of said space-time, that is the quantity measurable by clock and scale. There still remains the question of the intermediary quantity of what ds is, and that must be detected by the Fraunhofer lines. So he's saying like, okay, the trajectory changed, but how did that affect the how does that affect the material substrate of the curvature of space-time, would be essentially would be what he's trying to imply here. But like, remember, they don't even interpret that as a physical, structure. So he's just kind of kicking the buck a little bit. On the question of whether the eclipse results confirmed Einstein's general theory of his law of gravitation, the published paper seems to be a little ambiguous. On page 292 of the published paper, Dyson and others, the following two statements occur within the course of a single paragraph, emphasis added. The results of the observation here described appear to point to a definite point appear to point quite definitively to the third alternative and confirm Einstein's general theory of relativity. But whether or not the changes are needed in the other parts of the theory, it appears now to be established that Einstein's law of gravitation gives the true deviation from Newton's both laws for relatively slow moving planets and fast moving planets and moving waves of light. If there to be a fair comparison between the critical assessment of scientific papers and critical assessment of the candidate for canonization performed by the devil's advocate, all the available facilities should have been placed at the disposal of the assessor in each case. Although Silverstein did not have enough information about the eclipse observation at the meeting, he made the following criticism at the meeting of the Astronomer Royal in their joint meeting. All right. Stone G, do you want to take over for the rest?
Sure.
All right.
The eclipse observations, indicate the presence of other factors modifying the displacement of stars. These displacements are not radial. The deviations from the radial direction are marked running up to 15 degrees for star number 6 and to 35 degrees for star number 11. 5 of the stars near the sun's axis show deviations from the radial displacement in the same sense. 2 stars near the sun's equatorial plane show angular displacements in the opposite sense. If we had not the prejudice of Einstein's theory, we should not say that the figure strongly indicated a radial law of displacement. It seems reasonable to suggest that the prestige of Dyson and Eddington led to the arranging of the joint meeting before the paper had even been received. Suggest, eh? And to the rapid acceptance of the paper when it was received. In this connection, it is interesting to note the comment by Wally about the influence of prestige on meetings of the Royal Astronomical Society, that papers had to be submitted a week before, by the first Friday of the month. Papers submitted by people like Eddington, Jean, and Milne were always read, and they always came first. Boy, does that guy sound bitter or what? Although it seems obvious that no independent critical assessment of the results was made before the joint meeting, with information still available today, it's possible to make some assessment of those results. As various authors, such as von Kluber and Bertotti, Brill, Krogdorff, have pointed out, other scientists have reassessed the results of the 1919 and other eclipse results with a certain amount of variation from the results originally published. For example, Sciama in 69 refers to a table of results of eclipse observations from 1919 to 1952 and comments as follows. It's hard to assess their significance since other astronomers have derived different results from a rediscussion of the same material. Moreover, one might suspect that if the observers did not know what value they were supposed to obtain, their published results might vary over a greater range than they actually do. There are several cases in astronomy where knowing the right answer has led to observed results later shown to be beyond the power of the apparatus to detect. Airman Bondi has strong supporter of relativity, makes the following comment on the subject of Einstein's prediction of the deflection of starlight by the sun. Einstein's prediction can therefore be checked only on the rare occasions when, at the moment of an eclipse, bright stars happen to be near the direction to the sun. The effect is difficult to study even when circumstances are most favorable. The indications are much in favor of Einstein's theory of relativity, but it would be premature to call the results conclusive. If it was premature in 1960 to call the results conclusive, it was much more so in 1919. Another interesting assessment of the significance of the 1919 eclipse results has been given by Calder in 79, who wrote, "The eclipse results were a triumph. Newton's ideas about gravity had reigned unchallenged for more than 2 centuries, yet within 4 years of Einstein developing his theory, it seemed confirmed, and Newton was dethroned. The deflection of light by gravity is, as I have stressed, central to Einstein's general relativity, but later measurements of the deflection of starlight at other eclipses gave a wide scatter of results. They departed from Einstein's prediction by anything up to 60%. The difficulties of the observations were to blame rather than any defect in the theory. While they did not allow any restoration of Newton, they left, nevertheless, a little elbow room for alternative accounts of gravity." So, 60 years after the initial triumph, astronomers and relativists were decidedly cool about this way of checking up on Einstein. With reasoning like that, the theory cannot lose. If the experiment supports the theory is confirmed. If the experiment does not support the theory, it is the difficulties of the observations that are to blame, not the theory. From reading the many accounts of the way in which the results were obtained, it appears that the evidence for the bending of starlight by the sun was rather flimsy in 1919. Now, let's consider another of the results of the general theory, namely its explanation of the movement of the perihelion of the planet Mercury. Alrighty. As already mentioned, the general theory included a formula that correctly matched the variation in the perihelion of the planet Mercury. Python 82 has given the following interesting description of Einstein's excitement on discovering his explanation of that phenomenon. The discovery was, I believe, by far the strongest emotional experience in Einstein's scientific life. Perhaps in all his life, nature had spoken to him. He had to be right. O. Polkinghorne quoted Pye's statement and made the following comment. It was a great triumph, but if the answer had not come out right, the aesthetic power of the equations of general relativity would have been quite unable in itself to save them from abandonment. It was indeed nature that had spoken. It should be pointed out that exactly the same formula as Einstein published in his general theory for the variation in perihelion Mercury had been derived by another scientist several years earlier, using another method based on the assumption of a retarded gravitational potential, which was Gerber in 1898. Some of the reactions to Gerber's paper have been described by Folsing. In particular, Folsing described the action of physicist Ernst Gehrke, who had written articles against relativity since 1911. As no one believed his refutations, Gehrke in 1916 opened a second front. He unearthed some studies by the Pomeranian schoolmaster Paul Gerber, who, about the turn of the century, had tried to explain the perihelion movement of Mercury by procedures which were entirely arbitrary and were rightly rejected by astronomers. By reprinting Gerber's paper along with his own comment in Annalen, Gehrke insinuated first that Einstein was a plagiarist, and second, that the problem of the perihelion precession had been solved before relativity. According to Folsing, Einstein did not publish a reply to Gehrke's paper, but he did publish a brief note in reply to another paper by Gehrke. However, although in that paper Gehrke had mentioned Gerber's formula, Einstein's reply, which Folsing described as concise and factual, did not mention Gerber. Einstein did, however, mention him in a later article in which, after agreeing that Gerber had given the correct formula for the perihelion motion of Mercury before he himself had done, Einstein continued as follows. The experts are not only in agreement that Gerber's derivation is wrong through and through, but the formula cannot be obtained as a consequence of the main assumption made by Gerber. Mr. Gerber's work is therefore completely useless, an unsuccessful and erroneous theoretical attempt. I maintain that the theory of general relativity has provided the first real explanation of the perihelion motion of Mercury. I have not mentioned the work by Gerber originally because I did not know it when I wrote my work on the perihelion motion of Mercury. Even if I had been aware of it, I would not have had any reason to mention it. Oh, wow, how the guilty bark. In the same article, Einstein referred to criticism of the eclipse observations as follows. Mr. Gehrke, in his lecture, has made the masterfully executed English measurements of the deflection of light by the sun appear in a bad light by mentioning the three independent groups, only one of which, because of aberration of the heliograph mirror, gave erroneous results. He has suppressed the fact that the English astronomers themselves, in their official report, considered the results as a brilliant confirmation of the theory of general relativity. In view of the many subsequent criticisms of the eclipse results, it appears that the confirmation of the theory may not have been as brilliant as those who obtained the results believed. It also seems unfortunate that Einstein based his claim of Gerber's errors on an appeal to the authority of the experts instead of indicating what was wrong with his derivation. Another dismissal of Gerber's work is mentioned by Folsing in the following words. A sharper, crushing reproof came from the respected Munich astronomer Hugo Ritter von Seeliger, who pointed out that the Pomeranian schoolmaster had copied things which had long been known to every worker in the field, and that his so-called explanation was based on a crude mathematical mistake. Unfortunately, Seeliger does not seem to have identified the crude mistake, and Roseveare has made the following comment in his reply. Seeliger claimed that Gerber's calculation was based on an elementary mistake, though it is evident that it was Seeliger who was mistaken. Unfortunately. Also, Folsing does not say why Gerber's methods, as he put it, were entirely arbitrary and were rightly rejected by astronomers. It is also unfortunate that Gerber, having died sometime between 1902 and 1917, boy, that's quite the margin, was not available to defend his work from Einstein and Seeliger. Okay, since Gerber's 1898 paper and Garrick's references to it are in German, British scientists may not even have been aware of them in 1919, so that Gerber's work was not taken into account in considering possible alternatives to Einstein's theory. Simply pointing out Gerber's earlier derivation of the formula in question is not, of course, accusing Einstein of plagiarism, since Gerber's derivation of the formula was different from Einstein's. Although Roseveare gives a sympathetic description of Gerber's work, he states that his law was refuted on 2 counts. The first count was the fact that Gerber's theory is a gravitational theory and says nothing outside that sphere. This problem is apparently avoided by general relativity because, according to Roseveare, this theory already contains special relativity. That claim is debatable, at least, and we shall argue below in our discussion of special relativity that special and general relativity are distinct theories. Neither one contains the other. Roseveare continues his claim that Gerber's theory has been refuted by saying the second count on which Gerber's law may be seen to be refuted is the deflection of light rays, though this was at times rather equivocal. In view of the above discussion of the accuracy of the light deflection results, this reason does not appear to be decisive. Perhaps it might be interesting to take an objective reappraisal of Gerber's work. We are at special theory. Although the above discussion concentrates on general theory of relativity, there are also some anomalies in the history of special theory. When the special theory was first published, it was taken to be similar to theories of others, such as Lorentz, Poincaré, Larmor. For example, Whittaker mentions Einstein's theory in passing in a chapter entitled The Relativity Theory of Poincaré and Lorentz, in the following words. In the autumn of the same year, in the same volume of the Annalen der Physik, as his paper on the Brownian motion, Einstein published a paper which set forth the relativity theory of Poincaré and Lorentz with some amplifications and which attracted much attention. Although the special theory did not have a very large impact before the rapid rise of the general theory in 1919, the events of 1919 caused it to become famous also, even though it is a different theory. So here's what Cohen wrote about the way the events of 19 contributed to the rise of special theory. In considering relativity, we must keep in mind that there are 2 different theories of relativity. But what brought the attention of the world to special relativity was the verification in 1919 of a prediction of the general theory that starlight passing near the sun is bent by the sun's gravity. The verification, which occurred during a solar eclipse expedition, sent into being the relativity craze that swept the world and overnight made Einstein a public figure. It is time to realize that even if the general theory were verified, that does not in itself verify the special theory. The 2 theories are different. They do not use the same set of axioms. The difference is shown by the following statement by Stachel. Theory of relativity is an umbrella term covering 2 quite distinct theories, usually called special and general. The exact nature of the relation between the 2 is still a subject of controversy, and both might well not bear the common appellation relativity, if not so closely associated with the work of one man, Albert Einstein, who developed the second in attempting to extend the first to include gravitation. So one is a band-aid for the other, folks.
One says the speed of light is constant, and the other one says it's plus or minus v.
That's right.
It's crazy.
That's right. Dig in, boys, dig in. Okay, various authors have tried to explain why the results of the eclipse observations were announced as being decisive when they're not. For example, Ehrman and Gleamer wrote, Eddington's over-enthusiastic advocacy may perhaps be explained by his prior conviction that the theory was true, and by his interest in saving something from the vast work of the Principe expedition. Dyson's position might be understood in part as the result of a reasonable evaluation of the evidence, and in part as the result of Eddington's advocacy. But one retains the suspicion that besides these reasons, there was, especially for Eddington, another. The hope that a British verification of Einstein's theory would force on British scientists a more open-minded and generous attitude towards their German colleagues. Oh yes, I'm sure this is all about international politics, people. Yes, we've got to cut them slack because, you know, we killed all the Nazis.
That checks out.
And their families. And everybody else. You know what I mean? Oh my God. The enormous public reaction to the scientific announcement appears to have been strongly influenced by the ending of the war with Germany, and it may be noted that another important historical event of 1919 was the signing of the Treaty of Versailles over German protest in June. Chandrasekhar has described how Rutherford attributed Einstein's great fame to Eddington and explained the public reaction in the following words. The war had just ended, and the complacency of the Victorian and Edwardian times had been shattered. The people felt that all their values and all their ideals had lost their bearings. Now, suddenly, they learned that an astronomical prediction by a German scientist had been confirmed by expeditions to Brazil and West Africa, and indeed prepared for already during the war by British astronomers. Astronomy had always appealed to the public imagination, and an astronomical discovery transcending worldly strife struck a responsive chord. The meeting of the Royal Society, at which the results of the British expeditions were reported, was headlined in all the British papers, and the typhoon of publicity crossed the Atlantic. From that point on, the American press played Einstein to the maximum. It may be argued that the inaccuracies in the 1919 eclipse observations do not matter, since the same effect has supposedly been verified by more accurate measurements, such as, for example, the measurements on quasars described by Maddox. This point of view is somewhat guardedly espoused by the last paragraph of the critical discussion of the 1919 eclipse observation by Ehrman and Gleamer. This curious sequence of reasons might be cause enough for despair on the part of those who see in science a model of objectivity and rationality. That mood should be lightened by the reflection that the theory in which Eddington placed his faith because he thought it beautiful and profound, and possibly because he thought it would be best for the world if it were true. This theory, so far as we know, still holds the truth about space, time, and gravity. That is at least debatable. For example, Chandrasekhar made the following comments on a lecture in which Dirac had claimed there was a long and impressive list of successes of Einstein's theory of gravitation. It does not seem to me that the successes of Einstein's theory are either long nor impressive. It is true that his prediction of the different rates of clocks and locations of different gravity, his prediction of the deflection of light when traversing a gravitational field and resulting in time delay, his prediction regarding the precession of the perihelion of Mercury, and finally, the slowing down of a binary star in an eccentric orbit by virtue of emission of gravitational radiation have been confirmed quantitatively. But all these relate to the departures from Newtonian theory by a few parts in a million, and of no more than 3 or 4 parameters in a post-Newtonian expansion of Einstein's field equations. And so far, no predictions of general relativity in the limit of strong gravitational fields have received any confirmation, nor are they likely in the foreseeable future. Oh, wow. Okay, it's also reasonable to ask whether the rapid and strong entrenchment of the general theory that occurred as a result of the eclipse announcement may have led experimenters to try to obtain the right answers from their own observations, as suggested in the above quotation by Shiana. For example, Collins and Pinch have commented on the measurements of the redshift predicted by general relativity as follows. The experimental observations conducted both before and after 1919 were even more inconclusive. Yet after the interpretation of the eclipse observations had come firmly down on the side of Einstein, scientists suddenly began to see the confirmation of the redshift prediction, where before they had seen only confusion. Ah, the Messiah is here. I see the light. No pun intended. Another unfortunate result of the announcement of the success of the eclipse observation has been an enormous hero worship of Albert Einstein, which continues to this very day. Pace's statement that he was canonized has now been outmatched by Miller, who states that he was deified. A result of this deification is the greatest scorn of the scientific community is reserved for those who would try to criticize either of Einstein's theories of relativity or to suggest alternative theories, and many mainstream scientific journals reject papers critical of either theory without review. The attitude of most journals is well described by Davies in the first sentence of his article, Why Pick on Einstein? Does this sound like the song about Charlie Brown? Why everybody always picking on me? Most editors of scientific journals make special provision for coping with the huge influx of papers and letters, many bearing private addresses in California, purporting to disprove or improve Albert Einstein's monumental work on the theory of relativity. Yeah, okay, open a new department, guys. Cope, all right? That's how fast information is being created. Great. What's the actual problem there? The assessment of scientific theories and criticisms of them should be based on the merits of each case rather than on the addresses from which they come. Although Maddox describes more modern ways of measuring the deflection of radiation by a gravitational field, he appears to be willing to consider the possibility that general relativity may not be the last word. The last paragraph of his article is as follows. The crying need remains what it has been for the past 2 decades, that of marrying together general relativity and quantum mechanics. As things are, they're like chalk and cheese. It'll be a great surprise if general relativity survives that marriage unchanged. It's just about anybody trying to survive a marriage unchanged. I love the metaphor. Okay, so anyway, or the simile, I guess. As pointed out by Ehrman and Glimmer, it was Eddington's belief that confirmation of Einstein's prediction had a beneficial effect on scientific relations between England and Germany, like that matters at all. And it is fair to ask whether that beneficial effect was sufficient to justify the announcement of the results as being decisively in favor of Einstein's theory when they weren't. It is also fair to ask today whether continued belief in the decisiveness of the results as announced in 1919 is beneficial to science and scientific objectivity, or whether scientific progress would be improved by a more open acknowledgement of the inaccuracies and uncertainties in the observation. Even if it is argued that Einstein's general theory has been supported by subsequent experimental observations, that does not alter the fact that at an extremely important scientific meeting, which had enormously far-reaching consequences, the audience was misinformed by eminent scientists about the phenomenon that was the main theme of the meeting. That historical fact has not wiped out by any subsequent experimental results, whatever they may be. Because of the euphoric veneration of Einstein and relativity in November 1919, the objectivity with which science is supposed to act has been compromised, and the search for better theories has been inhibited. Canonization, deification, and claims of personal communication from nature should have no place in science. If the findings of the eclipse expeditions had been announced as being inconclusive instead of decisive in 1919, general relativity would have had to compete with other possible theories, such as Gerber's, to explain certain astronomical observations, and a better theory might eventually have been found. In the author's opinion, the confident announcement of the decisive confirmation of Einstein's general theory in 1919 was not a triumph of science, as is often portrayed, but one of the most unfortunate events in the history of 20th century science. Oh yeah, Now that's a punchline.
Crazy, dude. I forgot about.
Very, very Stephen Crothers yet again. Fantasyland.
Yeah. Ian McCausland's awesome. He's written some great stuff
Yeah, that was a
to
nice little
showcase
paper.
this. I totally
20
forgot
page
about
Wonderama.
the radial dispersion aspect of the starlight displacement. Like the fact that it's not all radial is just like that. That in and of itself is game over. That's crazy.
Gay as fuck is what it is.
Well, you're not wrong. But real quick before we close out here, I wanted to showcase a couple of things that I learned from the making that spreadsheet the other day.
Oh yeah.
So check this out. So it was stated in here that Gerber's mechanism, well, first of all, it was stated that he made a math mistake or something, but no such math mistake was ever cited. And that's because he didn't make any and they're all fine. And his starting premise was starting with Newton's laws of motion. He had a differential equation for that, started with that, and then reduced it all down to kinematics. And what he came out with was the same equation that Einstein would later use and solve, just rearrange it and solve for a different variable in it. Because if you have all the parameters, you're going to get the correct result. So
I smell authority-based gaslighting.
Oh, dude!
Oh no, you made an elementary error. No. Yeah.
Dude, of the worst kind. The story on Wikipedia, if you go to Wikipedia and go to Gerber controversy, it's like what they said about it is ridiculous. And then you could go and read his work. It's just like elegant and straightforward. It just involves like algebra and a little bit of calculus, and then he just reduces all that down to what he started with. After accounting for conservation laws and all that, he gets left with just kinematics with this equation over here on the left that I solved for. So there's no dynamics in any of this. All we have is just the observation. So the period and the semi-major axis, which is just a ratio of pi over the periodicity to establish what the dimensions of the
distance and time
of the distance would be for that orbit. So with that, we can derive literally everything. So like the GM amount, the gravity amount, you can derive all of that. You can convert that into kinetic energy potential. You can convert it into gravitational potential. All of that just comes from just the kinematics that Gerber derived. This equation is actually the backbone of modern physics in terms of astronomy, because it's presented that it's from Einstein, but remember, this guy derived it perfectly under a completely different premise. So the way that Gerber did his equation was he solved for the speed of light and was saying that was the uh, speed of the gravitational wave in the same medium that light's in, which is dictated by epsilon and mu over here. So just the vacuum properties. So the way that this equation writes out, instead of C being in here, you could actually replace it with just the vacuum properties. And the way it solves out, it gives the same exact answer. So it's another way that you could word this, and this is what Gerber's interpretation was, because it was an ether theory, was that the motion was retarded due to the vacuum properties, essentially like the physical properties of the medium. And so he derives the correct perihelion precession here for Mercury, 43 arc seconds per century. And then also I have the dynamics that are associated with all the planetary bodies and whatnot. All those relationships can be derived here from the same thing. And then more importantly, everything that comes out of Einstein's field equations that's supposed to be mutually exclusive to dynamics, so mass and the big G, the gravitational potential, everything that comes out of this. So these values here are orbital decay over an orbital cycle. So how many when they break it down into like seconds per second, it's a really, really small number.
Does that third one you just clicked there, right? Yeah, that one.
Yeah.
Is that unit of measurement micro arc seconds per year?
Yes. This is
and it's 1 times 10 to the negative 4 micro arc seconds per year. We're talking in excess of billionths of a 3600th of a degree per year.
Well, this is actually a time unit. So this is 0.75 microseconds, I think it is, something like that. So, or no, wait. Sorry. This is for the sun and Mercury. That you wouldn't do these calculations for our system, because like you're showing here, like you said, these are so small it's ridiculous. These are relevant more for this system here, where it's still obviously ridiculous, but Let's see. So this is for the S2. Was that the binary stuff? Yeah, there we go. So this is for
Okay, that's a slightly bigger thing. That's
Yeah.
7 seconds per year. Okay.
Yeah, so this is for a binary star or binary neutron star system. So what we're often told is that the Kepler's laws only hold true in our solar system, and then once you get out into the big solar system, you have to account for dynamics and the relationship between mass canceling out, is only for our solar system because the sun's so big. But it wouldn't work if the masses were close together to one another, like in terms of how much they both weigh. So in this system here, this binary neutron star system, both of the masses are almost equal. They have a ratio here to of their dynamics here that's almost one. So their masses are very close. So they're like this equation shouldn't work then anymore. It should break down, but it correctly derives what relativity predicts through using field equations, just using kinematics. And the reason for that is because all of the variables that they use asserting for dynamics are just ratios of the kinematics themselves, and it's always just velocity over it's just position over time. It's always just velocity and ratios of that to this medium apparently, is how this whole system works. So this is this is supposed to be a huge confirmation and success of relativity theory, yet it's derived entirely of kinematics. The whole orbital decay down to how much it is per year, and then we can also derive the Schwarzschild radius of a so-called black hole. We can predict the deflection of the how much angular deflection there's going to be. So in the example of Mercury, how that guy said that Gerber's theory was falsified by deflection. Well, the only thing you need to add in here to get the deflection angle is the assumed radius of the sun, and that'll give you 0.75 arc seconds when you solve like when you solve the same equation just using kinematics. So the whole entire model, gravitational redshift, that redshift amount that the boys were looking for uh, during the eclipse, all of that is derivable from this as well. And also the Shapiro delay is derivable, and that's it's like a delay in gravitational, or it's a delay in radiation output due to gravitational potential. So we the whole the whole entire model is derived on relative velocity to a medium, but they've dressed it up in field equations and dynamics variables that don't actually mean what they're claiming that they represent. I shouldn't be able to represent their entire model just using what Gerber showed in the 1898. That would be crazy. So, but yet it's here and unfalsified. So yeah, that was an awesome read through to go through the history of that, and how it also incorporated Gerber in it in his equations and the history of that. Because the only answer to this, like Stone was saying, is just academic gaslighting. You can't refute this. This is just math of ratios of velocity converted into a different ratio, and then that ratio used over and over again. That's all it is. All right, so that concludes research and reading night. Did anyone have any thoughts or questions or comments to add on to that?
Nope.
Nope. All right, cool. Well,
Happy crowd.
shout out to Ian McCausland. We'll be back next week, lads, for another research and reading night and or Prezi night. And then Friday, we'll be back, of course, for the Friday Community Twitter Space hosted by Ken and Brian Sweet. Shout out to the
Hey,
lads over on
I,
Twitter. What's up,
sorry.
Lily? No, you're good. What's up?
I have a quick comment. You know, I think it's really odd that all the planets show that they have this um perihelion aphelion type of elliptical orbit around the sun, according to globe science. But the moon does not have an elliptical orbit, like a perihelion aphelion orbit around Earth. That's very odd. And I'll bet you.
Oh, actually, it does. It is asserted by Globes that the moon has an eccentricity of 11% of a perfect circle, so that technically is an ellipse, but it's very close to circular.
Huh.
Indistinguishable, almost, some would
it,
say.
so it's not as extreme as, let's say, our orbit, huh? I mean, around the sun. Is that what you're saying?
Well, no, I'm just talking. I just quantified it for you. Like when you in arithmetic terms, we talk about something that is perfectly round. It's got an ellipticity of 0%, right? And there's an 11% change away from perfectly circular, which is how they describe the orbital shape of the moon.
On Earth, according to them. Is that what you're saying?
Pretty close
Yeah.
to
then
circular.
Yeah.
I do find it anomalous, though, that the really circular orbits are Earth around the sun and the moon around Earth. That in terms of eccentricity, those two particular values are quite low.
all right.
Yeah, if you want to take a look at the E values here, they're all right here.
Oh wow. Oh, let me screenshot this. Shoot. Screen shoot. Okay, good. Oh, thank you. I don't know why I thought that the orbit of the moon around Earth, according to them, was perfectly circular. I mean, I know that it's at an angle to our ecliptic, but I didn't know that the circle itself was not a real circle, like a round circle, but it was actually elliptical. Oh, what am I? That's not the right word. What is the word when you have aphelion and perihelion? Because that's not a perfect circle, right?
Perigee and apogee?
Maybe that's what I meant.
Yeah, they refer to an ellipsoid or an elliptical path.
Oh, yeah, because I'm not talking about the angle of the elliptical. I'm talking about the shape of the circle that's they
Indeed.
suppose. Yeah.
Yeah, the
And
top view,
yeah.
Uh-huh.
its actual circular shape, not its angle compared to another angle of a path. You're talking about the shape of the path itself, irrespective of
Right.
everything else.
Right. Right. And so the moon's is not perfectly circular, is that what you said?
Yeah, it's out by 11%.
11%. And what is the Earth's percentage? 3%?
Well, right there, Alan's got it at 1.67, but I don't think that's correct. I think that's an inversion. That is a different calculation than what I'm thinking, what I saw, or used
Well,
even in computing the gravitational calculations that I did for the Earth Moon video last. Couple thoughts about the moon, more thoughts about the moon. That's the figure.
all right. Never mind. Thank you. I should look into this more. I'm just interested in knowing. Thank you.
All right. Well, we will be back later in the week, and then, of course, next week.
Happy Easter.